we have two sections to cover today. Like I said, jump in with me, pay attention, because we must get through all of this. So, lecture 18, we're talking about savings formulas and annuities. Some terminology we need to know. Typically, we have what's called a nominal rate, or a nominal interest rate. The key thing about nominal rates is it does not indicate or take into account the compounded interest. It's just a straight up interest rate. Now, however, there is something called the effective rate. So you have a nominal rate, plain old thing, doesn't include your actual interest, compounded interest, right? The effective rate, however, this one does take into account compounding. Once stated per year, the effective rate is called the effective annual yield, or EAY. If you're talking about saving money, it's the same calculation, you just give it a different name, because instead of spending, you talk about saving. That is your annual percentage yield. Okay. I'm sure you've watched car commercials or seen commercials for banks and loans. You've seen things like EAY and APY. That's what they're talking about. Now, the effective rate per period. This is the simple interest rate, keywords there, simple interest rate, that produces the same amount of money as when the account is subjected to compound interest. Okay? So effective annual yield. You've got simple interest, you've got compound interest. Right? Say you have an account, you put some money in, it has compound interest. The effective annual yield is the simple interest that gives you the same amount of money as if you were using compound interest. Okay? So it uses simple interest to give you the same amount of money that you would get if you were using compound interest. Here's your formula. And again, it depends on what you're talking about. If you're talking about saving money, then we use the APY, annual percentage yield, or borrowing money in this case. Think about taking out a car loan, right? That's why we always say that the APY is 4.19%, something like that. R, as usual, is your interest rate per compounded period. N is still the number of compounded periods for your investment. Same thing as that chart that we saw on Monday. Same values.
Ms. Kieran,
yes.
Can you explain the 1 and why the 1 plus? I don't understand that.
It's just how it is. That's just how
Where does that come from?
Honestly, I can't give you that answer without going into some heavy analysis. At this point, take it at face value. The only thing we can tell you. Let's apply this. All right, we have a savings account, and it has a nominal rate of 5%. So remember, that's just a regular interest rate, but it does not take into account compounding your interest over a certain period. Okay. But we're going to say that we compound this daily, and we need to find the effective annual yield. And we're going to assume that we have a bank that's open 360 days a year. We take 5 days off of federal holidays. Okay. Here's what we do. Use our monthly formula. So the EAY is equal to the quantity of 1 plus R over N, so your rate over the number of times compounded, raised to the nth power minus 1. So there's the formula. Let's plug in. So we've got 1 plus our rate is 0.05 over, for compounding daily, but the bank is only open 360 days a year. You're only compounding 360 times. Raised to the power of 360 minus 1. All right. Punch that into your calculator. And we have to simplify this inside part first. So 0.05 divided by 360. We've got the quantity of 1 plus 0. I've got 0, 0, 0, 1, that, use your carrying function. You should end up with, let's see, I've got 1.051267, and then minus 1. Which leaves us with 0.05127. That is a decimal. What's the percentage here? 5.13%. So here's what's going on. You have your savings account, and they say you have 5% interest rate on your savings account. Sure, that's not fine and dandy. But what's actually going on whenever you include the compounding, you're getting more than just 5%. You're actually getting 5.13% interest on it, okay? Because of the compounding. Possible exam question. Be able to calculate the APY for 5.3% compounded quarterly. So again, this is the same formula, right? But it's just a different context.
One day last week we were talking about the calculations, the formulas, and you counted out the 5 decimal points in that particular formula. Here you went, however many that was.
I was
that
trying
based
to
on-
be thorough. Yeah, for that
Okay.
calculator right there,
Okay.
the more decimals, the better.
Okay.
Next up, annuities. Okay, and annuity is a sequence of equal payments made at equal time payment, or time periods. For example, car payments. You pay a certain amount for your car payment every month. That's an example of annuity. A mortgage. You pay a certain amount for your mortgage every month. Another type of annuity. Okay, you can also consider it as a deposit. Every month, say you take $50 out of your paycheck, and it's automatically deposited into your savings account. It's another type of annuity. The value of the annuity is the sum of all deposits, here's the key thing, plus the interest paid. That's the value of your annuity. Here's an example. Say you deposit $1,000 into a savings plan at the end of each year for 3 years. This could be something like an IRA, some type of retirement plan. Okay? The interest rate is 8% per year, compounded annually. Find the value of the annuity after 3 years. Okay, that's part A. And then for part B, find the interest. So part A, here we go. At the end of the first year, you put in $1,000. Okay, so you haven't earned any interest yet because it's the very end of the first year. So you got $1,000. Okay, then we move into year 2. And at the end of year 2, you put in another $1,000, but you earn interest on the original $1,000 that you deposited in the first year. Okay. So that leaves you with a new grand total of $2,080. Okay. So now we're going to move into year 3. In year 3, first you have to have the interest that you earned off of the deposits from the previous 2 years. So we've got our $2,080 times 1 plus our interest rate was 0.08. We are compounding once a year, so that's over 1 to the first power, right? But then remember, you also value at the end of that year. Right? So you have interest earned off of the previous 2 years plus the $1,000 that you deposited at the end of this year. Let's simplify. You punch all this into your calculator, you should get I got $22.46.40 plus the $1,000 on the end, which gives us a grand total of $32,046.40 at the end of the third year. On your own, go through and do these calculations for yourself. I'm trying to save us some time here. Question?
What formula did you use?
This formula comes from right there. We're talking about effective annual yield.
So how come you didn't minus 1?
Say it louder.
How come you didn't minus 1?
Because that's what my notes told me to do. We're just going to run with it. That's what I've got in my notes.
So are we going to be,
My supervisors.
are we given these values
You
like the
will be
value?
given formula sheets, yeah. Yeah. You
So
will
the
be given
question
all
will
that.
include the data that it says value at the end of the year 1
Yeah.
and all that is going to be given?
Yeah, that's part of the example. Part B, find the interest. Okay. So, we said, to find the interest, all you have to do is subtract the amount that you actually deposited. Well, how much have you actually deposited into this account? 3,000. You deposit 3,000 at the end of the first year, 3,000 at the end of the second year, 3,000 at the 1,000 at the end of each year. Okay. So let's make a note of that. That's how much you actually deposited. Well, we said that we had a total of $32.46.40. Okay. So to find the interest, you subtract. So we made in interest $246.40. Just subtract. Now, for the previous example that we just did, we did 3 lines, right? 3 calculations for each year. Okay. Well, that's all fine and dandy if you're only trying to find a value after 3, maybe 5 years. But what if you want to find a value after 20 years? You don't want to have to keep doing that calculation 20 times. So as a shortcut, we have this formula instead. This way you don't have to keep recalculating over and over and over again. So the value of D is the deposit made at the end of each year for your annuity. Then, of course, you still have your interest rate R, the number of times compounded is N, and the accumulated value, or the value of the annuity at the end of your time period, A. Let's apply this. So we have someone who saves $100 a month, and they have direct deposit of this $100 into a credit union account every payday, which is the last day of the month. The account earns 5% per year. Compounded monthly, how much will this gal have at the end of 6 years? Assuming that her interest rate is locked in, that it won't change. Here we go. We use our formula from that previous slide. So A is equal to D, the deposit amount, times. Across the top, 1 plus R over N, raised to the NT power, minus 1, and then across the bottom, divided by by plugging in. So the deposit amount is $100. And then on the inside, across the top, that's 1 plus our interest rate, 5%, so 0.05, over the number of times compounded. Well, it says we compound monthly, so it's going to compound 12 times. Raised to the 12 times 6, right? Times 6 years, we're compounding 12 times. Then we have a minus 1 across the top, all over that 0.05 over 12. Okay, so we're going to rewrite, and the first two things we got to calculate are these three things boxed in red. Here's the three values, so you punch in your calculator and then rewrite. So A is equal to 100. We're going to leave that alone for a bit. Times. Okay? We have 1 plus 0.05 over 12. Gives us, let's see, 0.004166667. We're going to raise that. 12 times 6 gives you 72. And then you subtract 1, that's the top, over that 0.05 divided by 12, that's your 0.004166667. Let's simplify. So the next thing you got to do, put this together, and then raise it to that power of 72. Okay. And I've got A is equal to 100 times. Putting those two values together, 1 plus 0. Blah, 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 raise it to the 72 power. That's going to be 1.34901177 minus 1, still over all of this stuff. Okay. Next thing, subtract the 1, and then divide by that. And I've got A equals 100 times 83.76419. Multiplied by 100 gives us a grand total of 8376. Let's round that off to the nearest 100. 42. That's your dollars and cents. So if she deposits $100 a month for 6 years at an interest rate of 5% compounded monthly, she ends up with $8,376.42. Not a terribly bad investment. Next up, you got to be able to go the other direction. So sure, you want to be able to know how much money you have at the end of a certain period of time, but what if you're saving for retirement or you're saving for college? You got to be able to find out how much money you have to start with, how much you should be depositing each month. Here we go. So we have a couple, they want to save for the college education of their child, and they want to start saving a certain amount of money every month after their child is born until this child turns 18. They want to end up with $100,000. Now they need to know how much do they have to save at a 6.5% interest rate in order to get $100,000. So we're solving for one of the other variables. So it's the same formula, it's just we're plugging into a different spot. So the accumulated value that we want to have is the $100,000. What we need to find is plus our interest rate was 6.5, so that's going to be 0.065 over, let's see, how many times are we compounding? Compounding monthly, so over 12. And we are compounding 12 times a year for 18 years, minus 1. All divided by our interest rate, 0.065 over 12. Okay, so our goal here is to solve for D. We want to know how much to deposit every month. Here we go. Same routine. First things first. Simplify these three values. So we've got $100,000 is equal to our deposit times, okay, I went ahead and did some of this. Across the top, after you simplify the two boxes in red on the top, add the 1, raise it to the power 7, so forth, you should get 2.11835,712, and then across the bottom, 0.00541. 6, 6, 6, one more 6, and a 7. All right. That ends up becoming $100,000 equal to D times the number 408.3388981. How do you solve for D? Divide away the stuff you don't need. When you get to this part, the last step is division. So divide by the 408, yada, yada, yada. And you should get that D is equal to 244.89. So they need to deposit at least $244.89. They want to round it off to a nice 250. They could end up with over $100,000 after 18 years. Question?
For some reason, every time I try to put my calculator in the first part, it gives 0. Yeah.
And that has to do with the settings for how many decimal places are displayed. Which first part are you trying to do?
The 0.065 divided by 12, carry key.
Okay, you have to do each individual piece. So in the last example, see how I wrote out, see the box in red, and then up here, I turned the 0.05 into that decimal, 0.00166, yada, yada. That's what you have to do over here. So rewrite the 0.065 over 12 as 0.005416667. Then add 1, and then raise that. Okay. You have to go piece by piece. I don't have the time or the space to write it all out here.
I need to move the decimal place over 1.
Say it again.
Because my answer I got 3.211835711. Can you just move the decimal place over 1?
You shouldn't have to move the decimal for this problem. You can just pop out the answer. Yeah. On the previous one, on anything where you're looking for a percentage, then you have to move the decimal because the answer will be the decimal. Move it over to write it as a percentage.
Okay.
All right. Now let's determine the value of an annuity. So the previous example was find out how much you have to deposit every month to get a particular amount of money after a certain amount of time. For this one, say you have a retirement plan, you want to know how much you're going to have when you retire. So this is similar to the future value that we talked about on Monday, the future value of an investment. Okay, some idea. At age 25, we deposit $200 into an IRA at the end of each month with an interest rate of 7.5% compounded monthly. Okay? How much will we have at age 65? Okay, let's do part A first, and then we'll find the interest. So we're using the same formula. Our accumulated amount is $200 deposited every month divided by, how many times do we compound? It's monthly, so it's 12. And we are compounding 12 times a month for, well, how many years? You start at 25 and you end at 65, 40 years. Minus the one on top, all divided by 0.075, all over 12. So again, you'll have to start by doing these three pieces, and you'll do a rewrite for yourself. Okay, rewrite everything out. After you simplify the top part, you do 1 plus whatever that first box in red turns out to be. Raise that to the power of 12 times 40, and then subtract 1. You should end up with 200 times 18.898885, I think that's another 9, over 0.00625. Okay. So simplify this part on your calculator. Do a rewrite. 200 times that gives you 604,764.43. So $604,764.43. Okay. For part B, you have to be a little bit clever. How much are you depositing every month? $200. And if you deposit $200 a month, that means 200 times 12 gives you how much you deposit in a year. So you're depositing $2,400 per year. But you're depositing this over 40 years, so you gotta multiply times another 40. Which means in total you've deposited $96,000 over 40 years. How do you find the interest?
Subtract.
Find the difference. So you take your ending amount, 604,764.43, minus how much you actually deposited, so minus your 96,000, which means our interest was a whopping $508,764.43. Okay, so that is savings. Possible exam question. How much will you ultimately have in your savings account if you deposit $50 at the end of each month for 10 years at 5% interest compounded monthly?
Can you go back, start and say last answer?
That one?
multiple questions.
Yes.
I just want to make sure I heard you right. So we're going to get formula and test formulas?
Yes, you get formulas on the test and for the lab.
Okay.
For quizzes, there's only like 2 formulas, so if you study, you don't really need. Okay, are we good? Loans and amortization. Okay. At some point in our lives, pretty sure that most of us are going to have to take out a loan. Okay? So here's some of the math behind how they calculate your interest rate and your actual loan payments and what's actually happening when you're paying off a loan. So if you have student loans, same idea. This is exactly what's happening and why you have to pay a particular amount to pay off your student loan. Couple things we need to know about first. Terminology. Mortgages. Okay? Mortgage, long-term loan, buying a house. Down payment. Okay? Initial amount you have to pay right, before they give you the house. The amount of the mortgage, okay, so how much you're actually financing is the difference between the sale price and the down payment. So how much you're actually buying it for minus the down payment. Whatever's left, that's what you're actually financing. You have mortgage brokers, right, the people who take your money. Fixed rate mortgages, these are nice because it will always be the same payment. It won't change. But sometimes you run into things called variable rate mortgages and adjustable rate mortgages. Not always so nice. You won't always know what you have to pay the next month. Okay, computations. Things you have to know terminology-wise for our formulas and word problems. Points are a one-time charge that equals 1% of the loan amount after the down payment is made. So, say you have a $100,000 house and you pay 1 point on the $100,000 house, you're paying 1% of that at closing. Sometimes you'll be asked to pay 2 points, 3 points, just depends on how money hungry your broker is. So 2 points means that you have to pay 2% of the total loan amount at closing. Something important if you do end up looking into buying a house, the Truth in Lending Disclosure Statement shows you the actual APR for your mortgage. Okay. And the last little bit, some lending institutions require that part of your monthly payment gets deposited into what's called an escrow account. This is money used by the lender to pay real estate taxes and insurance and politics. Now, in your book, or if you look online, that's online text, this is the ugly formula that they give you. We're not going to use this formula. Instead, use the ones in your lecture notes. Okay? So don't use this one. This is the formula we're going to use instead. Just because this looks a little bit more familiar compared to the other formulas we were using previously. Okay? So same tax calculations, it's just different context. So, amortization formula. 2 sides to it. That left side should look very familiar to you. Okay? That stuff on the right, the stuff we just did. Okay? The deposits. The left side is our compound interest formula from Monday. Variables still stand for the same thing. All right, let's talk about buying a house. The $195,000. Holy crap. The bank requires a 10% down payment and 2 points at the time of closing. Okay? Well, the cost of the home is financed with a 30-year fixed rate mortgage. That's nice. You always know how much you have to pay. At 7.5% interest. Okay, first things first. Find the required down payment. This is what you have to give to your broker right off the bat. Well, if we want 10%, you just take 10% of the sale price. So 0.1 times 195,000. So that should be $19,500. You got to cough up before you can buy your house. Okay? Find the amount of the mortgage. Well, if you're already paying $19,500, the amount you're actually financing for the mortgage is the $195,000 minus that down payment. You don't need to finance money you already paid. Put that in your calculator. So you're actually financing $175,000 and 0 cents. $175,500. There we go. Now, how much must be paid for the 2 points at closing? Okay, so this is that little extra bit of money you got to give the broker for helping you find this house and so on and so forth. You know, it's like a finder's fee. Okay. We take the mortgage amount, and if we want 2 points, that's the same as 2%. Okay, so 2 points is 2%. So we do the same calculations, but remember we're only taking 2% of what's actually being financed. So 2%, 0.02 of not the original selling price. How much is actually being financed? The $175,000 and $500. $175,500. Why is it so difficult to say? So the extra fee you pay your broker is $3,510. So you have your down payment, you have how much you're actually financing, and then you have the extra fee that you have to pay your broker. Now, find the monthly payment. Okay. Gear up. Hang with me. We're almost done. If we're finding the monthly payment, that means we're solving for the variable D. Right? It's the same thing as a deposit. Right? The same principle. It's just the money doesn't go to you, you're depositing it for someone else instead. So let's plug in. The left side of this equation. The principal amount that we are actually financing is the $175,500 times 1 plus. Our interest rate was 7.5%, so 0.075 over 12, right? Because that's every month is how much you have to pay. And you're doing that every month for 30 years. This is equal to your deposit D times, fill in the rest, 1 plus 0.075 over 12 to the 12 times 30, and then you subtract 1, divide everything by that 0.075 over 12. I wrote 15, excuse me. All right. So notice you've got a couple quantities that are the same here. You can simplify this, simplify that, and that. And you can do a giant rewrite with all of these quantities. Okay. For the sake of saving time, since these are the same calculations we've been doing in previous examples, I trust that you can find these values for yourself. You should end up with, on the left side of the equal sign, 1653479.2 is equal to D times 1347.445425. And then as usual, the final step would be to divide away the stuff you don't need you should end up with D is equal to 1227. It says round your answer to the nearest dollar at the top of the example. So you're paying $1,227 a month for 30 years to pay off your $195,000 house. It's not too terribly bad. Financing to pay over 30 years. Okay, so if we're paying $1,227 a month, that means you got to multiply it times 12 to find out how much you're paying per year. And I've got 14,724. But we're paying this for how many years? Times 30. So you are paying 4, 4, 1, 7, 20. $441,720 is how much you're actually paying for your house. But you bought it for how much you financed? $175,500. Ouch. That means in interest, you're paying $266,220. Ugh. Ugh. Not so fun. We've got one more concept to go through. Promise, it's not that bad. So again, you have the answers to these calculations. Run through them again. Okay, for yourself. Write everything out. You have what the values end up being. All right, here we go. Possible exam question. Mo is going to take out a conventional loan to purchase a car. Listen to where it says conventional loan. Okay. The interest rate is 8.3% compounded monthly, and he has 8 years to repay the $12,000 he borrowed. $12,000 borrowed for 8 years. Find the monthly payments. Last thing we need to talk about, a loan amortization schedule. In fact, when you talk about something being amortized, you're actually killing it off. So you're killing off your loan payments. Now, think about a car payment. If you have one, it's typically the same amount every month, right? Okay. Well, even though it's the same amount every month, with each payment, you are paying more towards the principal amount borrowed and less of the interest earned. That's supposed to happen. And typically, when you take out a good chunk of change for your loan, your lender will give you a loan amortization schedule. So it actually breaks down your payments and how much is going to the principal and how much interest you're actually paying per payment. There are are two or three primary steps you have to go through with this. Let's take a look. Here's a schedule. We have an interest rate of 9.5%. The amount of the mortgage was $130. You plan on paying 180 times. Okay, 180 payments. And we have a monthly payment of $1,357.50. And this is going to be spread out over 15 years. Okay, so we have to find the first payment. First things first, you got to know your interest. All right, how much interest are you paying? Take your 9.5%. And we have to use that formula back from Monday where you take your, let's see, okay, I've got 1, 2, you take your $130,000 times your interest rate of 9.5, so 0.095, times 1 over 12, right? This is over a year. You're paying this once a month, so 1 out of 12. So that means I've got 1029.17. All right, that's how much I'm paying in interest for this first one. Okay, so let's fill that in. 1029.17. But notice, how much are you actually paying per month? $1,357.50. So your monthly payment, you take the $1,357.50 and subtract from that your interest. Leaves you with $328.33. So that means on your first payment, you're paying over $1,000 towards the interest of your house, but only $328.33 for the principal. Well, what about the balance of the loan? For that one, you only subtract the principal. So we take the original $130,000 and you only subtract how much you pay towards the principal. So minus $328.33 gives you $129,671.67. And just for reference, that way you can try this for yourself, the next line in your notes should be 1026.57 for your interest. For your principal, you should be paying more for the principal on your next payment. So $330.93. And then your new balance, $1,293.40.